Welcome to the course Business Analytics and Data Mining Modeling using R. In the previous lecture, we did multi-panel plotting. Now, in this particular lecture, we will start with in-plot labels. So, last time we also covered trend lines while we were doing multiple panel plotting. So, let us start with in-plot labels. Let us go back to RStudio. So, first let us reload the data and the libraries. Let us load this library XLSX and the used cars data set. You can see 79 observations and 11 variables. Now, let us recreate the age variable as we did in the previous lecture. First three variables are not important to us, so we are trying to get rid of those variables. Let us also convert these two variables, transmission and C price, as factor variables. Let us also eliminate that outlier point like we did in the previous lectures. Now, we are ready to go. So, we will start with in-plot labeling. So, in-plot labeling can be useful when we are when we are trying to understand a large amount of data, especially in clustering. So, it is easier for us to have a look at the make a visual inspection of the data and try to understand different clusters that could be there. So, we will start with a scatter plot with label points. So, this particular data frame we have already created DFFB. Now, there are few points. If we plot the if we draw this particular plot, if we create this particular plot between KM and price, there are few points which are far away from the major chunk of the points. So, therefore, we are trying to get rid of those points, so that we can go ahead with the labeling, because when we do labeling in the plot, therefore, it can be slightly messy if there are too many points far away. So, there is less scope for labeling in the major chunk of the points, So, therefore, we will try to get rid of these far away points. So, this is one, this is another one, this is the third one. So, these points we will try to get rid of, and then we will look at the. So, this particular plot, this scatter plot is between kilometer and price. So, let us look at the new range. So, you can see that this particular range 27 to 113, and the points that we have removed, they were slightly far away. You can see these numbers 160, 156, 167. So, these were the far away points. So, therefore, we wanted to get rid of these points, so that our labeling is much better. Similarly, for price variable also we have been able to get rid of the other points, this point 23 and 65. You can see that price value for these 2 points 72 and 13.55. These two, 72 is outlier and 13.55 is also far away from the major chunk of values. Let us execute the this particular code and create a scatter plot. So, these are the points between price and kilometer. Now, if you want to find out if you want to label these observations, so this is the text is the command which can actually be used. So, in the text command, if you are interested in knowing more about this particular command, then you can go into the help section and find out more information about this particular function. You can see x and y, the coordinates are first and second arguments. So, in this particular case, km and price, km on the x axis and price on the y axis, they are representing the x and y coordinates. The limits have been appropriately specified. You can see limits on x axis 25 to 120. This is again based on the range calculation that we just did. You can see the range, this is within this particular this particular limits. Similarly, for y axis also limits are specified as 1 to 9, and you can see the range for price variable is also lying within this range. So, therefore, this plot has been generated, and now let us execute the line to label this. Now, labeling is based on the variable model. So, the model name of the car would actually be the label for the points. If you are interested in re-looking at the data, so let us look at the first 6 observations. Let us scroll. You can see the second variable model. So, the name for each of the observation is going to be based on this variable. For example, Varna, Quanto, SX4, Beat, Civic. So, the points are going to be labeled with their respective model name. And then there are some adjustments. So, for every point where we want to place this particular label, so that is based on this particular argument adjustment ADJ. So, minus 0.4 and minus 0.4 are the relative coordinates from the points. So, from the x and y coordinates of the actual point, and relative to that coordinate, this adjustment is to be done where the label is going to be plotted. And the expansion for this expansion for these this label point is going to be 0.5, which is half of the default size. So, let us execute this line. You would see the plot is slightly messy now, but every point is labeled by their model name. So, all the used cars you can see they are labeled by their label names. Now, from here again you can see that on the upper side of upper half of this particular rectangle, this particular plotting region, you would see slightly expensive cars are there. For example, Rapid, Cruise, Duster. So, these cars Fortuner. So, these cars are in the upper side, Varna. So, these cars are on the upper side of price. So, which is very understandable. Now, you would see that in the lower in the right part, right rectangle, you would see the cars like which are having slightly higher mileage. So, those cars are there, for example, Desire, Varna, Indigo. So, all these cars you would see on this side. So, these cars are probably being used have accumulated more kilometers. So, this kind of clustering, this kind of understanding of data can also be helpful if the points are labeled. So, let us move to our next point. Now, large data set. So, if we are dealing with a really large data set, what is going to happen if we start our visual analysis? Our plot would be filled with many points, because we might be dealing with 3,000, 4,000, 5,000 or even 10,000 points. So, therefore, the whole plot, if we try to generate a scatter plot, the plot might be filled with too many points. So, how do we understand the relationships between variables or some information overlap? So, those kind of things, how we can find out. So, there we have a few things that can be done while we generate our plots, so that the we can easily see and understand the data. So, this is one example that one particular data set, promotional offers, that we are going to use. So, let us import this data set. You can see this particular this particular data frame df3 with 5000 observations. So this particular data set is will be in the large data set category, and there are just 3 variables but 5000 observation. Let's have a look at this particular data set. First 6 observations. So this particular data set has 3 variables. One is income, then other one being spending, and the promotional offer. So these 3 variables are about customers, the income of a particular customer and the spending that they do. So income and spending, and then the promotional offer, whether they accepted or rejected the promotional offer that was sent to them. So these we have these 3 variables, and using these 3 variables we will try to see how we can actually visualize this large data set and then try to understand. So again here our color scheme is going to be slightly important in this case. So let's check our default color scheme. You can see the black, red. This is the default color scheme in R. We can change it to gray and black. So our first color of choice is going to be gray and then black. So let's change it. Now when we are dealing with a large number of data points, then we will have to incorporate some transparent coloring, and we will also have to reduce our marker size. So the points that we generally see in our plots, so for example you can see these circles that we see in this particular scatter plot. So the marker size is slightly on the higher side for this particular plot. So therefore if we are dealing with too many points, let's say for example in this example 5000 points, therefore we will have to reduce the marker size, and we will also have to do a few more changes, we will see. So this particular plot, scatter plot that we are going to generate, this is between income and spending, income on the x axis and spending on the y axis. So let's check the range, 6 to 222, and for spending this is closer to 0 and then almost 11. So this is the range. The limits have been specified appropriately, and the labels and the color, you can see the promo offer, the third variable has been used as a color, and you would also see a plotting character is 19 has been specified. If you are interested in knowing more about plotting character, so plotting character is the one that is actually used to plot a particular graph. So you can see circles have been used in this scatter plot. If you are interested in finding out more about plotting characters, you can search in the help page, help section, and in the points function you would see there is a more description about plotting characters. You can see PCH values. So these are first 0 to 18, 0 to 18 and even more 0 to 25, they are well defined plotting characters. For example, what we saw in our scatter plot was similar to the PCH value of 1. Currently what we are going to use in this particular scatter plot is the plotting character of value 19. So that is this this dot, black dot. So let's use this particular plotting character. Cx is again the character this character expansion factor 0.8. So this is going to be 80% of the default size. Now we in the previous lectures we talked about how we can generate grid behind a plot. Now this is another way that we are going to use to generate grid. So in the plot function itself you can use this particular argument panel dot first, and there you can pass on the grid function which is going to generate grid for you, grid behind your plots. So let's execute this line. So this is our plot. Now if you visualize this particular plot, too many points, the clarity is lost because most of the points they are in the same region, so therefore they are overlapping each other. So this is what happens when we are dealing with large data sets. So it becomes slightly difficult for us to understand what is going on here between these two variables. You can also see the marker size is also playing a role. Because of this slightly higher marker size, many points are overlapped, which could have been avoided with a slightly smaller marker size. So let's do a few changes. So there is another concept which is called jittering, where what happens in jittering, to avoid overlap between points, we add some random noise, very small value compared to the actual value of that point. We generally add some random noise, so that two points which are overlapping, they might be slightly closer to each other, but both of them could be visible instead of overlapping each other. So this jittering is generally added to each point. So in this particular case, you would see that it is the income variable which we have selected for jittering. So income, so this particular x-axis points, so there has been some noise that is going to be added to all the x values for all the points. You would also see we have changed the plotting character. If we go back to the help section, you would see that PCS value of 20 here is actually for a smaller dot. So therefore the smaller marker is going to be used, and you would also see that character expansion also we have reduced it to 0.7. So therefore this is going to be 70% of the default size. So we have reduced the character expansion, we have changed the marker size, and we have also done jittering, which is adding the random noise so that the overlap could be avoided. So let's execute this line. Let's see this plot. Now you would see that many more points can be seen. So there is much less overlap. The marker size has reduced, so therefore points they are now the size is very small, but much less overlap between points, and most of the points, many more points in comparison to the previous graph can be seen here. Now you would see that most of the customers who have actually accepted the promotional offer, they seem to be lying on this region. They seem to be lying on the right and then the upper part, top right part mainly. Now there is another way to further improve this particular plot. So that is something that we have discussed in the previous lecture as well. Log scale. So we can transform our both these scales, x and y scales, and logarithmic scales could be used, and therefore that is further going to improve the our visibility of the points. If we again have a look at the plot, you would see that this particular region between 0 to 100, this is more messy. There are more number of points in this region. The other region is slightly there is some more space, the points are slightly more away, so therefore visibility of points is much better in this case. This region of 0 to 100 on x-axis, this is slightly more messier. So we will try to change the scale and try to see what can be done. So you would see that we have used the log argument in the plot function. Now x and y, the scaling of both the axes is going to be performed, and other things remaining same. Color, again promo offer is same is being used. Plotting character is same, and character expansion is also same. Grid is going to be there. So let's execute this particular line, and you would see a significant change in the plot. This is mainly because of the change in scale. Now you would see that because this being log scale, you would see the points, the space space between points having x values at 0 to 100, it is much more, and 100 to 200 less space has been less space is there. This is because of the usage of log scale. Similarly for y axis as well. So therefore now most of these points, they are more spaced. This region of points, they are more spaced, and therefore visibility of these points is actually improved. So clustering could be so this kind of a jittering and scaling of scales axes could really be helpful when we are trying to visualize a large amount of data, and it can actually help us, especially in unsupervised learning method tasks, especially clustering, and also sometimes to understand the relationship between two variables, especially when there are too many points. So let's reset the our color scheme for R. Now that brings us to our next discussion point. So we are now going to start our discussion on multivariate plots. So we are going to discuss a few of multivariate plots where not just two variables, more than two variables are going to be used. And because generally the kind of modeling that we do, whether it is for statistical modeling or data mining modeling, generally we are dealing generally we are in multivariate environment. So therefore multivariate plots can sometimes be more useful for us to gain some more insights. So we are going to start our discussion on multivariate plots. So first one that we are going to cover is parallel coordinates plot. So we will see later on as we go through this particular example what parallel coordinates plot is about. So for different variables, we can assume different dimensions are there, and for all those dimensions are actually given some space in our 2D plots. So we will see how that is done, and that gives us a better picture of each observation especially in parallel coordinates plot, and we can help understand what is happening between the data in the what is happening, the kind of relationship between variables and the observations as well. So to be able to use to create parallel coordinates plot, we need to load this particular library mass. Then we will also change, because we would be creating two back-to-back plots. So let's also change the parameters, two rows, one column. We are also changing this CEX value, margins and outer margins as well. So margins are specifically for the plotting region, and outer margins are the space between the plot and the remaining area. So let's execute this. So for this particular plot, we are going to use again df1. Let's have a look at the data frame. So this is the main data frame that we are going. So this is again used cars data set. So what we are going to do is we need to do certain transformation to be able to use the parallel coordinates plot. So if we look at the data that we have right now, look at this structure. Let's look at this structure. You would see that fuel type and transmission and C price, all of them, they are a factor variable. But parallel coordinates, this function pair coord that we are going to use now, this actually requires us all the variables to be numeric. So therefore we need to change them. So you would see this is one way. So all the labels, so fuel type labels, we are trying to make them numerical. For example, right now they are labels for fuel type, they are CNG, diesel and petrol. So first thing would be to change them to numbers. So this is the particular code that could be used. Length, because there are three labels, so therefore we can have 1, 2, 3 instead of CNG, diesel and petrol. So this is the code that can be done to change the labels name. So once the labels name have been changed for the fuel type, we are particularly ready to apply as dot numeric function to all the variables in this particular data frame. Earlier, even though we had two more factor variables, transmission and C price, but their labels name were already in the numeric form 0 and 1 and 0 and 1. So therefore, when we when we do the conversion for conversion of these strings to numeric, it is easier because they are already in the numbers form, written in the stored in the string form. So therefore, this particular variable fuel type that was stored using CNG regional, so textual form. So the name of the labels, they were text. So therefore, for that we had to change it. So let's change this particular function. Let's change this particular data frame. Let's have a relook at the structure. Now you would see all the variables are now numerical, and you would also see that labels have also changed. Now the values have also changed, especially for fuel type. You would see same is true for this transmission and C price. Let's have a look at the first 6 observation. You would see transmission, earlier it was 0 and 1, now you can see it's 1 and 2. This is main reason being because we have applied numeric function. C price also, earlier it was 0 and 1, but now it is 1 and 2. Fuel type, it was earlier text, that was CNG, petrol, diesel. Now it's 1, 2 and 3. Now once we have done this kind of transformation, now we are ready to use this particular function pair coordinate. Now here we are not going to include our outcome variable or interest. So there are two variables, price and C price. So price is not going to be included, price and C price is not going to be included in this particular plot we are interested in. So so we are going to use two panels and each panel for a particular group of C price. So for C price value 1 particular plot, one panel, and the second panel for C price value of 2. So that is the used cars with less than 4 lakh value. So they are going to be in the panel 1, and the used cars with more than 4 lakh, more than or equal to 4 lakh value, they are going to be in the panel 2. So we will try to understand the differences between these two groups across variables. So this is going to be multivariate visual analysis. So let's execute this line. You can see that panel 1 has been created. Now let's label the axis. Now you would see from here that pair coordinate function, it also scales all the variable into 0 and 100. So that is in percentage. So all the variables have been scaled, have been brought to the same scales. Let's also create grid. Now let's plot the second panel. This is in different color and labels and grid. Now let's zoom and find out the plot. So panel 1, this is for group 1, the panel 2, this is for group 2. Now from here we can actually compare these two panels, and we can try to understand the differences between these two groups. So as you can see, transmission, if we look at the transmission, then you would see the panel 1, right? The panel 1, there are two values that are there in transmission. So we had a manual and automatic. So there are two values. You would see in the panel 1, there are few values at the value 1, right? There are few values at value 1, and if you see here in the panel 2, so the values transmission for both these values, there seem to be equal number of observations. So equal number of lines are passing through this particular axis. For each variable, fuel type, SR price, KM, transmission owners, for each variable we have an axis. So that is why the name comes from this parallel coordinates. So for each variable we have coordinate system, and they have been put in parallel. So each observation, each line is representing an observation going through this particular plot. You would see fuel type. If you look at the fuel type dimension, you would see in the panel 1 petrol, CNG and diesel, all three are present, but if you see in the panel 2, only petrol and diesel are present. One is not there. One particular category is not present. So this kind of comparison can be done using parallel coordinates plot. Now let us go back, and so we are going to start now our discussion on next point, that is a specialized visualization. Till now what we have been doing is we have been mainly dealing with the cross sectional data or the time series data. Now we are going to incorporate some other forms of data. For example, in this particular lecture we are going to cover network graphs. So for that we require network data. So we will go through one example and see how it is different from cross sectional and data, cross sectional analysis and cross sectional data, and time series data and time series analysis. So this is this one hypothetical example that I have created. This is mainly applicable in the association rules context, that is going to be covered in a much later lecture. This is a bipartite graph, two mode graph. So there are going to be two groups, and we are going to see the interconnections between these two groups by plotting a network graph. So first what I am going to do is, because this is mainly in the association rules context, so therefore we are essentially dealing with the transactions. So therefore in transaction generally we have items which are purchased together. So we are going to create a hypothetical data set for the same. So let us say some items 1 to 10 they are represented by letters A to the corresponding one. So let us create this particular. You would see that item 1 has been created, 50 observations, and these and the labels 1 to 10. And now this is for the this is for the first item in a transaction. Second item in a transaction, again we are going to it is going to be from the same pool of items, but it cannot be the item that has been already purchased. So therefore we are going to we have written some code here to perform that. So first let's create this particular pool. This is 1 to 10. You can see here pools variable has been created 1 to 10, A to this particular value. Now what we are going to do, we are going to for a particular item in item 1, it cannot be included in the item 2. So therefore it is eliminated through this code. You would see minus which pool to lower item 1i. So item 1i in the uppercase we lower it down, and it should not, if it is equal, then that particular index is excluded from the pool samples from the pool from which this sampling is being done. So let us execute this code. Let us create the data frame of these two variables. So this I graph is the library that we generally require to deal with network data. So let us load this particular library. Now from the data frame that we have just created, let us have a look at the data frame as well. So you can see first 6 observation, items name. So we can consider this to be one transaction. Row number 1 is one transaction where items A and E are bought, purchased together. Row number 2 is second transactions. So these transactions based data set is mainly applicable to association rules. So now let us move on. So from this particular data frame we will try to create a network graph data. So this is the function graph from data frame that can be used. We need to pass on the data frame and the we need to set this directed argument. So in this case we are not trying to create a directed graph, so therefore this has been set as false. So let's execute this line. Now V is for vertices of a graph. Now labeling of those vertices. So till now what we have done, we have created graph. So if you want to see what we have done, you can see this graph has 20 vertices and 50 edges, and those edges have been displayed here, right. So now let's try to label these vertices. So labeling could be done using their name itself. So let's execute this. Now there are two groups because one is in a particular transaction, first item and the second item. So we are trying to put them into different groups. So 1 to 10 is type 1, and 11 to 20 vertices, they are type 2. So let's execute. We are trying to understand what generally happens in association rules, what goes with what. If item A is purchased, then whether item B is purchased or not. So in that kind of association we can see here through a network graph, where if in a particular group one item is purchased, then whether another item is purchased along with that. So we are going to find out that through network graph. So we have created two groups, then randomly we are trying to create the coordinates where these vertices are going to be plotted. So this is for the creation of layout coordinates. So this is again randomly being done. So x and y coordinates for all the vertices have been created. Now shape of the vertices we have selected right now circle, color gray. Now we come to our edge part. So edges the color has been selected black. Now sometimes there might be multiple lines between two particular items, because two particular items can be bought by more than one customers. So therefore there could be more transaction of that kind. So we are trying to represent a more number of transactions through the edge width. Therefore we are, instead of having 2 or 3 connecting points between two items, we are going to have just one connecting point with a increased edge width. So for that we need to compute the number of edges between two vertices. So that we can do using count.multiple function. Now we need to remove the if there are more than one edges between two vertices, we need to remove them. So we are going to do using a simplify function, remove multiple being true. So therefore those edges are going to be removed. Now we want to use that number of if there have been more than one edges between two vertices, we want to use that as a weight because we want to use that as width of the edge. So doing the same. Now let's come to our vertices. So let's if there are size of a vertex, we are trying to define by the number of edges that are coming in or going out of a particular vertex. So we are trying to compute that using this particular code. You can see. Now to have a better visualization, we have added 10 to each size for the vertex, for each vertex. Now let's change the parameter setting, margins, and plot. You can see this. This particular network graph has been created, and you can see this is the group 1. This is the first item that was purchased by different customers, A, F, E, and the second item that was purchased by the same customer. For each transaction we can see, and there is difference in the line width, that is actually signifying the more number of transactions. If that particular item has been purchased and the another item has been purchased in more transactions, so that is reflected in the line width. The bigger size of the vertex, that is reflecting the involvement of that particular item in more number of transactions. So therefore network graph can really be helpful in association rules while we are trying to understand the relationship between different items. So we will stop here, and the next class we will start with hierarchical data. Thank you.